So, Assalamualaikum and a very good evening. My name is Muhammad Ishazal Muhammad Hafiz. My matric number is CE 210 and 135. I'm from group 7. So, I will present and I will explain about why do we choose this this value at our transfer function using a PI system, PI controller, and by using a closed loop. So we choose this value because we use our control system from our previous subject last semester. So we use the assignment from our previous control system assignment, our previous semester. So I use it as our reference to use the transfer function value. Why? If you choose this transfer function, the output will be different and so on. So but the important thing is that the gain itself. So the gain we need to know from zero until from the lowest value until the highest value, what kind of output that we get from the scope itself. The transfer function can be anything, any value that you think is suitable for yourself and for the this closed loop type system. So you can use any type of transfer function, but you need to know why do you use that transfer function, why do you use this gain value. So we need to know from the lowest gain until the highest gain. So if I set it to the lowest, it's 0, starting from 0, you can see there is no output, it's just a straight line. It's just like a DC straight line, DC current, DC output. But if I put some values such as 2, you need to see the difference. So you can see the output itself. The output become like this. So the amplitude itself getting higher. Or we can say it in the alternating current, the output waveform, the signal itself is becoming stable. The stable itself means that the waveform itself is stable, but if I can show you, I will show how the unstable look. So I will choose 19 again. So you can see this is the unstable, the signal itself. It start from right. Commonly basically start from the left, but this time it start from the right because the signal become unstable. The highest the value of the gain, it doesn't mean it suitable for this transfer function, and it's getting the signal become unstable and oscillation. So our main goal is that to use a suitable gain for our group and use all the formula that given in the lab sheet to see that the difference between from the 0, the lowest value, until the highest value is 14. So those that simulation will be presented by a net presenter by my friend Siti Nur Ashikin, my group mate Siti Nur Ashikin, and other one is Soleha binti Ahmad. So they will be explaining why the gain is, you can see the difference in their simulation to see that the difference between the 0 until the highest value that we calculate. So thank you very much. That's all from me.
Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Nur Ashikin binti Muhammad and my number matrix is CA21021. Today, I will show the simulation of PID controller using Matlab. We have decided the maximum gain is equal to 19.5. Okay, firstly, I run the simulation when the gain is equal to 0. We set the value of K equal to 0 in command prompt. And then we run the simulation. And for the waveform, here we see there is no response because the gain is 0. To determine the parameter, we using the coding, which is runtime, settling time, and overshoot all is equal to 0 and overshoot is equal to infinity. Okay, next, for the value of k, which equal to 4.875. We run the simulation. Okay, here we see that the response has changed due to the gain is increased. This is because the controller has responded quickly than before. For the parameter, we input the coding. Okay, the rise time is become 0.1815, settling time is 2.3842, and overshoot is equal to 32.9110. Okay, that's all from me. I will pass to the next presenter for the other input gain. Thank you.
Okay, my name is Sarah binti Rahmat. My meter number is CE210227. So now the K we use 94.5, then we divide by 2, then we get 9.75. So this is the value we use in the gain. So after we run, we need to set encoding. Here. Step info, save out. We use name save out because in this the workspace, the name is here, save out and save out 1. So we use save out. Okay, save out data and save out time. So here we get the time rise is 0.1157, and the settling time we get 2.4538, and the MP or we call overshoot is 61.5923. So the waveform we get is here. This is the waveform we get, and when the gain we change the formula. The formula is given 90.5 is K, and then K is multiply with 3 and divide by 3 multiply with K 19.5 and we divide by 4, then we get Kmax we get 14.625. Okay, this is gain. Okay. Okay, we need to run. After we run, okay, this is the waveform we get for gain. So the waveform is increased because when K is increased, the PI control can lead to a more responsive and faster system, which can result in a more oscillatory waveform. This is because the controller is more sensitive to change in the error signal, and will respond more quickly to correct any deviation from the set point. So in the coding, we need to know the TR. Just write the same here. So we can just copy, paste, and then this is the value for TR, rise time 0.0939, and the settling time we get 8.5889, and the overshoot we get at 2.8179. So the waveform for the gain, increase gain, when the decrease the gain of PI control can result in more stable but slower system. So meaning that when gain is decreased, so the amplitude gets slow. When the gain is increased, what we call amplitude get faster. So that's all.